Hello students, this is another example of the distribution of sample mean. A population of values has a normal distribution with a mean of 17.2 and a standard deviation of 7.9. You intend to draw a random sample of size n is equal to 14. Then the questions are asked. Now we have two types of questions here, and we're going to dissect them and see what is the difference between the first question and the second question. So far, the intro is the same as the normal distribution that we studied before, except for the fact that we're offered a sample size here. So that is a big difference. This means we are going to talk about the distribution of sample mean at some point here. Now, to answer this question, we're going to first answer the first part of the question, and then we're going to answer the second part of the question. Okay. We have the population mean 17.2, we have the population standard deviation 7.9, and then the question asks, find the probability that is a single random selected value is greater than 13.2. So far, I don't have any changes here. We're selecting from the values of the population. So this question is related to the normal distribution, and we can treat it as such. We know that here is the normal distribution. The mean is 17.2. The standard deviation is 7.9. And we want to find the probability. So this is the area under the curve, meaning we're going to use norm dot distribution. Whenever you see the word probability, please write this down because that's the function that you're going to be using. Greater than means to the right. Greater than means to the right. You see, this acts like an arrow. That means this is the area to the right of 13.2. 13.2 is approximately here. To the right of that is all of this area right here. And we know to find the area to the right, we're going to use 1 minus norm dot distribution of the number 13.2 to the right of that number, comma 17.2, the mean, and then the standard deviation, and then comma true. Comma true, I'm going to write it here because it's out of the frame. Now we're going to compute that, and the answer is going to be 1 minus norm dot distribution of 13.2, comma the mean 17.2, comma the standard deviation 7.9, comma true. The answer is this. We're going to round it to 4 decimal places. Notice how we have extra directions for those students who are using the calculator. And for those students who like to use the standard normal distribution function, you need to turn your numbers into z-scores first and then work with them. For those who use Excel and use the normal distribution function, you don't need to do that. So this is just for the students who are strictly using the calculator, or they are using the standard normal distribution function. I'm going to round to 4 decimals, and then I'm going to go here and paste it. So that is the first part. The second part of this question, notice the difference in the way the question was asked. Find the probability. So I'm just going to write norm dot distribution. I need to use the normal distribution function. That a sample of size 14 is randomly selected with a mean greater than 13.2. So the difference here is it's asking if we select a random sample of size 14, what is the chance, what is the probability that that sample mean is going to be, the mean of that sample is going to be greater than 13.2. So this basically is saying, if you're repeating the process of pulling out samples of size 14, what is the probability that you're going to select a sample of size 14 with a mean that is greater than 13.2? So these are keywords. First, you're given a sample size. It's asking about the average or the mean is greater than or less than. So yes, we're going to use the normal distribution similar to this one, 1 minus, because it's greater than. But in this case, we have to come up with the new mean and new standard deviation, because this is basically the distribution of sample means. There is a sample and here is the mean. So the distribution of sample means the number at the bottom of that curve are basically sample means. we took samples of size 14, and then we created a distribution. The distribution requires a mean and a standard deviation. We know that the mean of the distribution of sample means is equal to the population mean, and we know that the standard deviation of the distribution of sample means is equal to the standard deviation of the population divided by the square root of the sample size. So the mean in this case will be equal to 17.2, and the standard deviation will be 7.9 divided by the square root of 14. So in other words, the mean here will be 17.2, and the standard deviation is going to be the standard deviation. The new one is going to be the old one divided by square root of the sample size. And those are the information we're going to use in that case. 13.2, the mean 13.2 is approximately here. Greater than means anything above that or the area to the right. To find the, 13.2 is approximately here. And then the area to the right is what we mean by greater than. So this is not right. Now we're going to use the same function that we used in the previous question, except for we're going to use a new standard deviation. That is the only difference. So my function is going to be 1 minus norm dot distribution of 13.2, comma, the mean, comma, the new standard deviation, comma, true. Now note that you can compute this outside and then click on the cell, or you can plug it into your formula. I'm going to plug it in my formula. It's just the way I wanted to do it. 13.2, comma, 17.2, comma, 7.9 divided by SQRT of 14, and then comma, true. And that is going to be the answer. I'm going to round this to 4 decimals, and then I'm going to copy it and paste it into my answer box. So that is the difference between the first part of the question and the second part of the question. Notice these slight differences. We're given a sample size, and it's asking about the mean. It's not asking about the value. And that means one thing, which is dealing with the distribution of sample means, which requires you to work with the new standard deviation. I hope this video helped you understand how to answer this question. I'll see you in a different one.